What is going on, guys? Welcome back. In this video today we're going to learn how to code a book recommendation system by utilizing large language models in Python. So let us get right into it. Alright, so we're going to build a book recommendation system in Python today by utilizing large language models. And I want to briefly sketch the process, nothing too complicated and nothing too detailed. I just want to show you basically here visually what we're going to do. Very basic. I'm going to use my mouse, so this is not going to be the most beautiful drawing, but our goal is to build up a vector store, so a vector database. I'm going to say VS here, vector store. And this is going to contain vector representations of a bunch of different books. So the idea is we have a data set full of different books, and these books have certain attributes like a title, a description, an author, a publishing date, and so on. So we have a bunch of attributes here, and what we want to do is we want to get those, build a textual representation, so basically just raw text containing this information in some way, and then we want to somehow intelligently take that and turn it into a vector. So all representation are going to be turned into vectors, and these vectors have some values. I don't know, 4, 0.5 something, and this is a very high dimensional vector. So I think, let me just double check here in my prepared code. This is going to be a 4096 dimensional vector, so it's going to have 4096 values, numerical values, which are not random, which are intelligently chosen, and then these vectors are going to be stored in the vector store. And when I get a new book with new information, what I do is I take that, turn it into the same kind of textual representation, turn it into the same kind of vector using the same model, so into the same kind of vector representation here, and then I ask what's the closest vector to this one. This is a similarity search. So mathematically, if I have 2 points in a 4096 dimensional vector space, there is a distance between all the different points. And what I'm asking is, using this new vector, what's the closest vector? What's the closest point in this high dimensional vector space to this one? And I assume this is going to be the most similar book. So I'm going to use the 5 closest vectors to determine the 5 most similar books and recommend them as a result. Now, the interesting part of this whole system is basically this arrow here, because that is the embedding process, taking text and turning it into a vector intelligently. And for this, we're going to use LLMs, so large language models. This is where the intelligence is needed, because we need to take a text and we need to somehow take the content of this text and turn it into something that is meaningfully represented in a 4096 dimensional vector space. And then we need to be able to do a similarity search there. So that's what we're going to do. Now for the embedding model, if you want to change the code to use something else, you can do whatever you want. You can use ChatGPT, so the OpenAI API, you can use GPT, you can use any kind of self-hosted model. I'm going to use Ollama just for convenience. Ollama, I have a video on this channel showing how to install and use Ollama. Basically, it allows you to easily run models locally. I'm going to use, I think, let me just double check here. I'm going to use Llama 2. Just because it fits into my hardware, and I'm going to use Llama 2 to get text, feed it into it, and get an embedding out of it, a 4096 dimensional embedding. And as a vector store, we're going to use Face, so the Facebook vector store. All right, and as a data set, we're going to use a Kaggle data set, which is the 7K books data set. The reason I chose this one is because it also has descriptions, so we have actually text describing the content of the book, not just the title, because the title can be very misleading or very simple. So we want to have these descriptions here as well. So this is the data set I'm going to use. You will find a link to it in the description down below. And actually, I think I have to download it because I don't have it in my directory. So I'm going to just download. I'm going to go to Python current. Here I'm going to download the archive zip. And in here we have the book CSV file. I'm going to extract it. And I'm going to just close this. All right. So now I should have the book CSV file here. I'm going to open up a new Jupyter Notebook instance, and we should install a couple of packages first. The basic data science stuff as always, so pandas, numpy should always be part of the equation here. And I think for this we're going to use Face as well, as I said. So we're going to use also the requests package because we need to send a request to the API of Ollama. And we're going to use Face, and then you can use, I think, Face GPU and Face CPU. I think I'm using Face GPU here. So this utilizes, of course, the graphical processing unit and not the CPU. But if you don't have a GPU, a strong GPU, you can also go with face CPU. But this is what we need for this video today. All right, so we're going to start by loading the data set and taking a look at it. This should not be too difficult. So the data frame is equal to pandas read the CSV file, which is called book CSV. And then I can look at it. Basically, what kind of textual representation you want to use is up to you. You can be creative with this one because at the end of the day, you want to pick a representation that contains only the necessary information, only the useful information. And you also want to structure it in a way that is the most useful for the LLM. Now, what this way is, I don't really know. You have to play around with it. You have to see if different representations give you better results. My approach here is to just craft a string saying, listing the specific information that we need. So for example, saying the title is this, the author is this, the publishing year is this, the categories are these, and so on and so forth. So yeah, this is the data that we have. I'm going to use the title, I'm going to use the authors, I'm going to use the category, I'm going to use the description, the publishing year, and maybe let's go also with the rating. So the rating could also be interesting because, yeah, I mean, if a book has an average rating of 1, it's probably not that good. All right, so what we're going to do is we're going to create a function which is going to take a row and turn it into a textual representation. So we're going to say textual representation. By the way, I have a very, very similar video where I do the same thing with movies. If you're more interested in movie recommendation, you can check this out. Today we're going to do books. So textual representation. We get a row as an input here. And then basically we just take the content of this row, so the title, the authors, and so on, and turn it into a string. So I'm going to use an F string here, a multi-line F string, so 3 quotation marks. And I'm going to say that this is the textual representation. And we're going to start by saying, first of all, the title of the book is row title, like this. Actually, shouldn't this... Oh, I'm using double. Why? Okay, we're not in Flask here. We use just single curly brackets. So this is the title now, and then I can do a line break, and I can say the next thing is the authors. The authors is going to be equal to row, and then authors. And then I can do the same thing for all the other rows, for all the other columns. So again, we have title, we have authors, categories, description. So let's go with description first. Description is going to be equal to row description, obviously. Then the categories, or maybe we should say, I mean, categories is fine. Maybe we should say genre, but I'm not sure about that. Categories. And then what did I say? We want to go with the publishing year and the average rating. That should be it. So we're going to go with publishing year. It's going to be row published year is the column name. And then finally we have average rating, row average rating. And I think one more feature that is useful is the number of pages, because maybe I'm only interested in very small books, so I usually only read books like 70 pages long. That might also be a factor, even though maybe not the most important one. So let's say number of pages is going to be equal to row num pages. All right, so that function takes a row and turns it into such a string. And then all I can do is, or all I have to do is I have to just return this textual representation like this. All right. So let's see what happens when I apply it. So let's go and say df and then ilog up until 5 and then apply the function textual representation. Do I have to provide an axis? I think so. There you go. So this function now applied gives us that. Maybe we can go values 0, and actually I can go and print that to get the result here. And you can see we get the title, the author's description, categories, publishing year, average rating, and number of pages. So that is what our function does now. Now we need to apply that function to all the individual rows. So we're going to say df textual representation is going to be equal to df apply textual representation axis equals 1. That is turning our data set into one where we have these textual representations here. All right. So we have this now, and the next thing we want to do is we want to take all of this and make an embedding and put everything into a vector store. So we're going to say here import face, import requests. Now we don't need to really interact with Ollama. The only thing that you need with Ollama is, of course, you need to say Ollama serve, I think, or Ollama run, and then you need to say Ollama pull llama 2. That's important because you need to have the model on your system. And again, I have a video on Ollama. If you have struggles with Ollama, check out that video. So import face, import request, and then import numpy as np. Then we say the dimensionality is 4096, as I said. And then the index, so the vector store is going to be face index flat L2 with the dimensionality here. We choose this dimensionality because that is the dimensionality of the response we get from llama 2 when it comes to the embedding. And then we want to say x is equal to np zeros. And here we pass length, data frame, textual representation, and dimensionality. So we just initialize these. Actually, we need to also pass the data type. D type is float 32. We just initialize input full of zeros here now. And what we want to do next is we want to actually get the embeddings from llama 2. So we say for I representation in enumerate. So we have an index, enumerate df textual representation. For that, we say take the representation and make a request. So say response is equal to requests.post, and now we just need to use the localhost URL of llama 2, of Ollama, sorry, which is by default HTTP localhost, and then port 11434. If you didn't change that, that should be the default port of Ollama. Again, here, if you don't want to use Ollama, you can also use the OpenAI API. There is an API for embeddings. If you want to replace this code with code that gets you the embeddings from OpenAI, where you have to pay money, you can do that. You don't have to do it with Ollama if you don't want to. You just have to get somehow the embeddings. So /API/embeddings. And here now we need to pass some data. The data is going to be a JSON object. And the JSON object will say, I want to use the model llama 2. And I want to use the prompt for the embedding, which is the representation. All right, so that is our request. And then the result is going to be, or the embedding is going to be equal to the response dot get the JSON and then get a specific field called embedding. And then in order to store that, go to index I. This is where we do the enumeration here. Go to index I and say that that is now our new input here. So np array embedding. Actually, I think we can also use np empty. That would save us some time, I guess, but it doesn't really matter. So yeah. And in the end, when we're done with that, we want to do index.add x. So we can do it like that, and it will take quite some time. So I can run this, and you will see it will start working, and it takes some time. So I can actually go ahead and add a line here saying if I modulo 100 is equal to 0, print I. And remember, we have, how many? We have 6,810 rows. So I can run this. You can see I get 0. Then at some point, I'm going to get 100, 200, and so on. But you see the progress is quite slow. So when you see 100 and when you see 200, you're going to see how slow this actually is. So I'm not going to do all of this here now on camera. And I think actually, Okay, it seems like I cannot run this while recording because it crashes my recording, or at least it makes it very laggy. But you can see it doesn't work very quickly, at least on my hardware. Maybe you have some power GPU and it works instantly. So you have to run this for a while. I'm not going to do this on camera. I already did this. This is why I have this index file here. I'm going to show you how to create that here in a second. But you can run this, for example, on the first couple of instances if you want to. You can run it on the whole data set and just wait. But the idea is that once this process is done, so once this loop here is finished and you add everything to the index, what you can do easily is, let me just close this here. What you can do easily is you can export the index by saying face write index, and then you take the index and you save it to index. Now, in my case, I already did that. So I'm not going to do this, but this is the line of code you would run to do that. I'm just adding a 2 here in case I accidentally run this and delete my index. And what you can do then is you can load the index from the file again by saying face.readIndex and then just a file name, so index here, and then you can store that in an index. So in this case, what I'm doing now is I'm loading the index from a file instead of creating it here by training, because I already did this exact code here. I ran it, I waited, I produced the index, I wrote it to disk, and now I can just say index face read index, and I have the full index. So everything that is the result of running this, just that I now terminated that, but I now have the index, and this is now the same thing that you get when you just run this and let it run until it's finished. Or you can also go ahead and just truncate it. You can say, okay, give me a random sample of the data. I don't need all of it. It's up to you. So it takes some time. Now, what do we do with this index? What we can do with this index now is we can provide a new instance and find the most similar instance of the database. So for example, let's use from our data frame here. So let's go and say data frame df where the title contains, let's look for a book. Classic self-improvement book would be something like How to Win Friends and Influence People. So let's look for friends. What's the problem here? Df title contains, title dot string contains. So we have Little House friends, How to Win Friends and Influence People. There you go. Or actually, this is the book. So it's 4533. Let's say I want to find the most similar book to this one. Now, this is not a new book. You can also do that with a book that is not part of the data frame, but then you would have to craft your string yourself. But let's go and say that my favorite book now is equal to df ilog, and it's 4533. So if I look at my favorite book, you can see it's this one. I can also look at the textual representation here, and I will get the data for the book. Now, let's say I like this book and I want to find similar books because I want to learn more about this or similar topics here. What I can do is I can use the vector store to embed this again, and this could be something completely different. I could go ahead now and craft this myself. I don't need to use a string that is already part of the data frame. I can go and say title Python Bible 7-in-1, which is a book from me. I can say authors, my name, and I can put my book here if I want to, and I can feed that in as well. So it doesn't have to be a book that's already part of the data frame. You just craft your string and you feed it into it. It doesn't even have to have the structure. So you can also go ahead and feed in hello world and embed it. It also works, but it's not very useful. So we have this book here, and what I want to do now is I want to embed this again, assuming that this is not part of the data frame, or you can again embed your own string, and then take that embedding and perform a similarity search. So we do that again by saying basically the exact same thing that we did here. So we're going to copy that code. The response is equal to request post and then that, but here now instead of representation, we pass favorite book textual representation, or you could also, as I said, pass your own string. Yeah, so that is that. We get a response from this. Now we need to get an embedding. So what's the embedding of this particular book? It's equal to np array of response.json. Yeah, we need to actually use this thing here for the shape. So response.json embedding and then the data type is equal to float32. This is now the closing bracket. Actually, we need it like this. There you go. So that's the embedding, and now we have to feed this into our index and search for similarities. So we say di is equal to index search. So we perform the search based on the embedding, and we're interested in the top 5 results. So I pass 5 here. And then I can get the matches by saying best matches is equal to np array df textual representation. So I get only the column with the representations from the data frame, and I say that I'm interested in particular in a couple of indices, and these indices are what I get as a result here from I. So I flatten that. Because what you need to understand is that I'm doing this, and as a result, I don't get a textual representation. I get positions, I get indices of the individual entries, and I then need to translate them back to actual representations from the data frame. So I can say for match in best matches, print the match, print an empty line, and basically run this. And you can see now, not surprising. Actually, this is surprising because this is not what I was expecting. Let me see. This is, I think the issue is that... Okay, so I actually figured out that the problem was a different one, and it was that I was not using the exact same structure that I was using when training the previous index, because of course I trained the index with my prepared code, and there I had a slightly different structure. Now I changed this. You can see now title is no longer the first thing. We have categories, title, authors, average rating, number of pages, publishing year, then a blank line and description, not because that's necessarily the best way to do it, just because that's the way I did it when I trained my index, which I loaded. So this is just the reason you want to keep this the same. You cannot train or you cannot build your vector store with examples like these and then use a completely different structure. So you have to keep it the same. In your case, it shouldn't make a difference. You should get good results immediately because you have only been using one structure. In my case, it made a difference. So just as a side note here, it's good that we can learn from mistakes. You need to keep this the same. So you cannot just swap things around here because it's going to mess up the database. So I changed the structure to be the exact same as the one I used. So now I can run these things here again. I'm not going to run this one. I can read index. I can find this book again. I can post, I can get the best matches, and then I can get my results, which are in this case now way better. Now, of course, this one here is going to be number 1 because it's the exact same thing. But besides that, we have here Conduct of Life from Stephen Covey, also a self-improvement book. We have Psychology, The Dance of Intimacy from this author here. We have Marketing in the Bottom Line. Oh, actually, this was not the type. Conduct of Life is not the type. First Things First is the type of the book. And The Dance of Intimacy is the title of this book. So this is just a category here. But yeah, so you can see that what we get here, how to talk so teens will listen and listen so teens will talk, yeah, whatever. But these are all like self-improvement / productivity / communication books. Maybe we can go and look at a couple more here. And we see that for the most part, Art of Happiness, these are all self-improvement books. So it seems to work to some degree. You can play around with that. You can play around with different representations. You can also try, first of all, smaller samples and then do it on the whole vector store or on the whole data set. But this is how you can build a recommendation system, because all you have to do now is you have to come up with new books like in this structure here, and then you can just feed them in and get recommendations for similar books. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.